Hi, good morning. My name is Cliff Loudon. I work at SAF AQRE over at the Pentagon. I am the MOSA PEM and the Air Force DEPSO. So I'm looking forward to speaking with anybody interested during our breakout session at lunch. And since Ms. Baldwin is my boss, I hope that spurs you to think about questions later on during the audience participation portion. But before all that, I'd like to introduce our panel of distinguished guests here. From the Air Force, we have Christopher A. Garrett. He is the senior level executive and technical advisor for systems engineering at the Air Force Lifecycle Management Center over at Wright-Patt Air Force Base in Ohio. He serves as the recognized Air Force authority for systems engineering for weapon systems lifecycle management, charged with providing technical oversight and advice to the high-level Air Force and government officials. In this role, Mr. Garrett is the lead engineer developing the Air Force Material Command strategy for digital transformation. He has spent over 27 years of active duty service in the Air Force, working in the areas of electronic warfare, test, space, and aircraft sustainment. And while on active duty, he spent 2 years at Robbins in Georgia, leading the C-17 group. This is in addition to several other wonderful positions and accolades, but let's cut it off a little bit short there so we can keep it going. But ladies and gentlemen, Mr. Chris Garrett. From the Missile Defense Agency, we have the Deputy Program Executive and Technical Director, Ms. Linda K. Palmer. She is the technical director for MDA's Transformation Task Force. She leads the digital transformation efforts to maximize quality data and technology to support decisions and helps guide efforts to improve productivity and efficiency with agile workflows to accelerate fielding capability to the warfighter. She also chairs the MDA Cybersecurity Executive Steering Group. She's had previous assignments as a senior technical advisor for the ground-based weapon systems and acting chief engineer for the Terminal High Altitude Area Defense, as THAAD program over at Missile Defense. And she provides technical expertise and advice to the PEO for GW on program requirements, system integration, modeling and simulation and testing. She's a Project Management Institute PMI certified PMP as project management professional, and earned a certificate in systems engineering from the Naval Postgraduate School over in Monterey, California. She's a graduate of the Federal Executive Institute in Charlottesville, Virginia, and a slew of other accolades as well. But everyone, please join me in welcoming Ms. Linda K. Palmer. From OUSD Research and Engineering, we have the Director of Digital Engineering, Modeling, and Simulation, Mr. Daniel Hedema, where he serves, oh yes, I'm so sorry. Miss Linda Palmer again, and Mr. Hedema. So in her role as director, in his role as director, Mr. Hedema offers expertise to senior leaders and oversees policy, guidance, and foundational research throughout the DoD. And that will advance the workforce and accelerate the adoption of digital engineering under Mr. Hedema's leadership, participation in the community of practice, and interactions within the digital engineering body of knowledge, as mentioned by a previous speaker, have experienced significant growth as evidenced by more than 1,000% increase. Mr. Hedema holds a BS in Systems Engineering from George Mason University, a master's in Space Systems Engineering from Johns Hopkins, and is a certified systems engineering professional by INCOSE, and an expert in SysML. So that's very timely. Ladies and gentlemen, Mr. Daniel Hedema. And for our fourth panel member, he's the Director, Defense Standardization Program Office. You've seen him all week, Mr. Michael Hafey. He's the Director of the DISPO, which champions standardization processes, products, and services to provide the warfighter with equipment that is interoperable, reliable, technologically superior, and affordable. Mr. Hafey holds a BS in systems engineering from the United States Naval Academy, not too shabby, and a master's in engineering management from Old Dominion University. So, ladies and gentlemen, Mr. Michael Hafey. So, little bit of a confession. All this production has been an elaborate ruse for me to ask the questions that I wanted to ask of my senior leaders. But since everyone's here, please take the opportunity to think of some questions that you would like to address towards the end of the discussion. And, only 2 rules, I suppose, no blue and blue and no stump the chump. I think is a really good opportunity to pick their brains though. So with that, I'm going to take a seat and start asking those questions. Hello? Okay. For the first question, I'd like to target it to Mr. Hedema. What is digital engineering and what is not digital engineering?
So thank you. Really glad to be up here on the stage with my peers, and thank you everyone in the community for coming out and having this conversation. So when I think of what is and what is not digital engineering, I look at digital engineering as really the modifier to engineering. It is not a type of engineering, as in electrical engineering, mechanical engineering. Let's frame it as a modifier. It is digital systems engineering, digital mechanical engineering, digital electrical engineering. OPM defines 26 job categories in the 800 series. I have no expectation to ever see the word digital engineer as one of them. It should be very much focused on the application. So let's take that down a level. What does it really mean when we think about the application of doing those digital tools? For me, it's about enabling the engineers doing their work on a digital integrated ecosystem, the key word there being integrated, through the application of standards, both at the API and the file format level. The Department of Defense is massive, 700,000 federal civilians, 2.2 million active duty service members, north of 5 million support contractors. There's never going to be a single integrated ecosystem. The way we need to think about that from our scale is the application of strong standards to let us utilize as we think about moving data and models and our simulation results up and down the stack, be it from government down to our prime contractors, from primes on down to subs and all the way down, and then rolling all that data back up. That's going to require some strong adherence to standards that we're really looking to kind of invest in at the R&D level. So with all of that kind of integration of that ecosystem, we can actually start building out those digital threads for the program manager, for their ability to really understand how changes occur and really enable the engineering discipline to work in some sort of almost CI/CD pipeline approach where models are being updated, everyone has the views, we understand the processes, we can bring in manufacturing, we can bring in the kind of supply chain perspective earlier into the design cycle. With that, we can take that up another level and look at the digital tapestry. So for the department's ability, as we think about how to do mission and campaign level engineering, what does it look like when we can take these programs at these digital threads, weave them together to tell a digital tapestry perspective so we can actually deliver capability back out to the warfighter and understand what the impacts are of any individual system that's being delivered. And all of that is really to achieve the vision that our senior leaders are asking us to do. The Secretary of Defense and the National Security Strategy National Defense Strategy, talks about the need to accelerate, our need to deliver capability faster. And for my perspective, the application of digital engineering is how the engineering discipline drives that acceleration, is enabling us to continue to do more in digital models, design, test, develop, and then hopefully accelerate the delivery out to the warfighter.
Any thoughts you'd like to contribute on that? Anyone?
Yeah, I'll talk a little bit about what's not digital engineering. So PDF files, that's not digital engineering, even though it's on a computer. doesn't mean it's digital engineering. The reliance, especially the reliance on 2D and 3D drawings as your authoritative source of truth, that is not digital engineering. And if you need those drawings, there's nothing wrong with having a drawing. It's just that it should be a digital artifact of your model, and you should be the truth should be in the model. And we'll go, I think, more into what needs to happen. But I will just introduce that by saying that your model needs to evolve as you know more about your system.
Oh, yeah. My only thought on that is that in, I think, 15-ish or so years, I don't think we're going to actually use the term digital engineering. So I think that's just for perspective, right? I mean, I get it now why we did it. But again, just for perspective, I don't think we're going to be using that term. That's not an enduring term.
And I completely agree with that. I often joke about that there is no director of computer at the Pentagon walking around ensuring people are using computers. But the timeline is probably a correct timeline. As much as we all want to keep accelerating our scale challenges, we found an article that referenced the application of a typewriter in 2007 still being used at the Pentagon. So Windows 95, you can kind of think of being like the major turning point to the application of a personal computer. So that's over a decade of, and we found an article talking about a typewriter in 2007.
So I think for the Defense Standardization Program, that digital engineering is a driver for us. It's not the only driver, but it's why we're talking about digital standards. We've provided standardization content requirements in human readable products. And now there's tools, products, and processes being developed, used by engineers and by other communities. And in order for us to keep standards relevant and make them as efficient to use as possible, we need to think about how are we going to provide that same content in digital format. We first started talking about documents as digital data, but even that we've started to change how we think. Because I think as Linda pointed out, we're not talking about just documents. You heard Chris talk about the 3D models. There are other ways. We've got SysML. There are many other formats which we can use to represent data and represent requirements. And there will be documents in the future, but there will be other things as well.
Yeah, the documents will be generated by models.
And so engineering doesn't change. It's the tools that you use. It's kind of like how a cell phone is just a phone, and now the old way is the landline. So are we going to call what we have now analog engineering? No, yeah. Okay, so that was the easy question. So for the next question, I'd like to target Ms. Palmer. What does government do well in digital engineering?
Well, my trite answer is we write policy pretty well. But more seriously, we do use a lot of models, and I had mentioned this to Dan Hedema a couple of years ago, that at Missile Defense Agency, we use models. They're digital models. It's not digital engineering, but we used a lot of digital models in our hardware in the loop, environments, and we get a lot of test data from those. We are able to integrate different parts, land-based, sea-based sensors and weapon systems, and space-based, and the communication systems as well. And we can integrate those in that environment, run scenarios, and get meaningful data, good enough that DOT&E likes it, although they do talk to us a lot about the models not always being accredited. So that is something that we do have to work on. The DoD, I think, is very good at looking for better ways of solving problems for complex systems and systems of the systems. And I will say that at Missile Defense Agency, I told the director one time, we have a lot of digital rays of sunshine because we have little pockets in different areas that people are doing some really good work. And one of those, with our ground-based mid-course defense system, which requires digital engineering in the contracts, they have used in their system requirements review and their preliminary design review, they have gone through the requirements, decomposed them in a model. They've done it all through the model, not through documents. And one of the things they did was generate new requirements. And this was based on the decomposing the requirements. And they said, well, luckily we designed it and we already met it. But it was amazing to say, hey, there's a system that's been out since 2004. Initially, it's evolved since then. But to say that we have now new requirements for the system that is in the field already was kind of amazing.
Do you find that the use of DE has enabled like development of tests alongside the development of the system itself?
It's interesting you asked that because when we did a maturity assessment and asked people for a self-assessment, and the first response we got from some of the testers was, "That's digital engineering. It doesn't apply to me." And so there and other comments were, now that everything's in the model, now the real engineering begins over somewhere else. And so what we're trying to do now is make sure that people are using the model when we have test cases, and some tools actually help you build test cases. We want to put that data that you're getting from the test back into the model so your model evolves and becomes more and more like your system that's going out to the field or that may already be in the field.
So from an Air Force perspective, I think, and Phil and I work together very closely now, if I graded the Air Force, and I've been living this every single day for 4.5 years, because that was my job when I got hired back in February of 20, I give the Air Force, and so those are two really hard terms. One, the government is very big, so I'm just going to talk about the Air Force. And then two, the word well is also a really difficult word, right? Because it talks about relativity. So I compare ourselves to our industry partners that we deal with. And I would say that the Air Force gets a D- in regards to what we're doing with digital engineering today in our proficiency to operate like an enterprise. And that's where people, I think, lose track, is that, look, we can go hodgepodge and look at that example and that example and that example. But I look at the enterprise every day. That's what I do. I look at the entire Air Force enterprise, including our warfighters, all of them. And so I give us a D-. The good news is what we have been able to do over the last 4.5 years is the gap analysis, both working with all of our industry partners and internal. And so we are on a path. I don't know if you know, I'll close with this comment. So our 4-star in my command, Material Command, General Richardson, working through our SAE, Senior Acquisition Executive, the Honorable Hunter, approved 2 years ago a POM input of $164 million over the FYDP that starts next year in 25 to help the Air Force. Now, is it the other zillions of dollars that I know my industry partners tell me all the time that their company is spending considerably above 164 million? It's not, but it's certainly a start. And when I look at what we haven't been doing, and now that we have this POM, so we're on a very good path. I think we know what we need to do. We're going to keep chipping away at it, and so for that, I'm going to be positive and optimistic.
Yeah. We may not have the funding now, and that's okay. But I think we can claim the great success that we're starting to see without the funding. The sheer fact that we have the capabilities, that we have the techniques, that we're starting to see the change prior to any POM level funding is an impressive undertaking by the engineering community that we should celebrate and be joyful in how we're able to communicate this value and to take pocket change kind of money and actually make it have real impacts across the department. And I look at when we talk about the broader enterprise, the Army's kind of growing up into this right now. They are doing a lot at the secretary level, kind of identify. They just released in May their digital engineering strategy, where they're focusing a lot on the workforce and where they need to invest in technologies and pathfinding approaches and stuff like that. So it's starting to bubble up at that enterprise level. But then we see great successes at the kind of more tactical level too. The Army Corps of Engineers out of Vicksburg, yes, they have what they like to call their blue collar supercomputing. They let the Department of Energy to do the really fancy, expensive ones, and then the Army Corps of Engineer has the blue collar ones. But their capability that they're putting out there, where they're on the DREN networks, to really let the integration of models and simulations happen, is an awesome capability that we can take credit for as we see the application of digital engineering saving value or adding value and saving costs, reducing timelines. We've seen it across hypersonics and all sorts of programs where already that good engineering modeling and simulation has resulted in value back to the programs.
I mean, yeah, no, I don't argue with that. It's just, what is our North Star? What, when we say doing well, what is that in your eyes? And I know what that is in my eyes, right? And we've articulated that to our leadership. And I'm just saying, we're not doing it. We know what it needs to be, and we're going to get there because we're on a path to do it. We're just not doing it well right now.
So you fall into my Shakespearean wordplay trap of words meaning different things to different people, right? So that the use case is it has to be different, though maybe our end goal is always the same. So that's why it's really good to hear the different perspectives, especially between agencies. So on the next question, actually for you, Mr. Garrett, how does the culture within the DoD need to change to reap these benefits of DE?
Yeah, I mean, this is a complete business process re-engineering that we're going through, right? In DoD as well as industry, to be a model-based everything, which is what I call it, right? Yes, and the data along with it. So our culture, in one sense, is going to have to completely change to shed off the paper way we used to do business. And does that mean more people will be trained in SysML? Yes. Will more people know how to do PLM, whatever your tool is there? For sure. So the training changes, the way we do business, right? Eventually, we're going to give our RFP will be a model. I mean, we're absolutely going to do that. We have instances where we've done that today. So our RFPs will be models. We'll get them back. We're going to run it through the AI engine, and I'll tell you that day who wins the contract. That day, I'll tell you. So that's definitely where we're headed, and that's not fantasy, right? That's not far-fetched. We can see that today. That's where we're headed, but you have to do a lot of infrastructure, right? You got to get the infrastructure in place to do that with your processes. So our culture is going to change, our infrastructure changes, and that's just going to take time. Right, that is going to take time to get people into that mode of doing business. Our policies are going to be rewritten. So even though engineering itself, whatever it is, fundamentally electrical or structural, whatever, doesn't change, your processes do change. And we're absolutely, I mean, 5097, right, just came out. So I mean, yes. So if you just look at the tip of the iceberg, right, and then the 10,000 things underneath it that we're implementing, it's all going to change. And the culture, for sure, right? Old guys like me that are leaving soon. I don't know typically if you've studied culture change, which we have in the midst of this, right? The old people don't do well, right? You don't do well. And so, right, those people, if they're not going to get into this, will have to leave. And that's going to be difficult because we don't fire people in the government, right? So you are going to have this lag until either those people leave just through natural attrition and retirement. But the new people get it. I mean, we have our new interns, right, graduating from college. I mean, they're right in, for example, to SysML, right, which is all over the modeling, all over the digital principles that we talk about and use that term today. So yeah, I think the culture change is a phenomenon that takes a long time. As I've already thrown out the 15-year, statement, I think for the enterprise to completely change is going to take quite a while.
Do you think it's an age thing or a personality thing, right? So, to borrow from industry, a culture of dive deep, continuous learning, bias for action, those kind of things, that's something that could be taught to anybody if they wanted to, right?
Yeah, there's no doubt. If you any psychologists in the room today, right? I mean, plenty of books have been written on this. This is nothing new. So there's definitely an age factor to it. Absolutely. If you study history, and I'm an old guy. So the deal is, yeah, personality does affect it because I'm all into this and I am old. So, I mean, it's not absolute. But there are the frozen middle. We didn't get that term for no reason, the frozen middle. There's all kind of reasons why they're frozen and why they don't want to change, which is different than the old people. So yeah, personality plays on it, but there's plenty of studies and the human nature does not change. So it's a phenomena. If you don't understand culture, it will eat you every time.
So I'm a big believer that change happens first in yourself. And we can take that here in this room and go out into our jobs over the next year and go, how can I change my job so that way I can be better positioned to utilize these kind of digital tools, and then feed that success into celebrating someone else's change, and then use that to then go up to your boss and go, man, let's go change that. I'm doing that internally to my organization of trying to find ways that it's not necessarily digital engineering, but I am I hate email to just my passion of hate for email rages on. And so I force my team to constantly contact me in Teams. They send me a long lengthy email with paragraphs. I go, too long, did not read. Like, message me, call me, let's have a conversation. That culture change can happen at that small cycle, and then that can then feed to the other organizations. And so we're seeing teams start taking off more and more internal to kind of the R&E family across the government, because people like me are willing to push on this and say, no, that's not how we want to do it. I'm a big believer also in kind of following some of that history perspective. And so here's a fun little history lesson for you guys. In 1940, FDR established the Office of Strategic Studies. It is the predecessor of today's CIA. In 1944, they released the Simple Sabotage Field Manual. It was declassified in 2008. You can go to CIA.gov and download it. It is classic government efficiency in the sense that they took the actual book, they scanned it, it's slightly askew, there's weird stripes all over it. So it's the way you expect government efficiency to work. But you can read it, and there's some really interesting stuff about how to sabotage telephone wires and boilers, and go read that stuff. But then read the final section where it talks about how to sabotage an organization. And in that last section, and I want to highlight three major areas. The first is the fact that it says, always refer all matters to committee. Make the committees as big as possible, no less than 5. It says, another one that it always talks about is always, it uses 1940 words, practically always rehash past decisions, question whether or not we had the right to make that decision. And the third one was always about the never permit decisions to be made in order to expedite a process. Enforce everything always goes through the proper channels. And I always look at that and I go, man, are we is the process in the DoD. Are we sabotaging ourselves? And so that's why I really think it's critical for us in the room to look at that and go, I'm not going to accept that sabotage, and push back and go, stop it. Show me where in policy or law it says I can't do that. Don't accept the answer of this is how we've always done it. That's not how we're going to get ahead as we think about trying to compete with a near competitor world. If we fall back on this is how we've always done it. We need to find the new innovation ways within our own work units so we can deploy those out to the broader community. And that's how we're going to change the culture across the department.
Yeah, if I could add another, is that you have to show people that they can stop doing some of the things that they're doing today. Not everything that, all the documents especially. How do you, there's a lot of comfort in a document because you have a signed piece of paper that, so you know it's approved. And I asked General Collins, who's the director for Missile Defense Agency, said, so I have this thing that's signed. I know it's approved. How do I document approval in a model? And he sat back for a couple of minutes and then he just said, you said document. So anyway, so we didn't get that answer, although now we are calling it annotating approval in a model. The other thing that I wanted to do is say we are transitioning within MDA from using email, at least for coordinating things, to using Teams. And in the Transformation Task Force, we are trying to set the example and for the rest of MDA. So we are using that all the time for our get-togethers and our coordination of documents and briefings and that kind of thing.
So how much of that needs to come from the top down, do you think, to make that change?
So I would argue that it's already being asked from us. You can go read the National Defense Strategy. Even the National Security Strategy coming out of the White House talks about the need to accelerate, the need to accept more risk. That means that we can, as we're moving out, we can take places where we go, man, okay, before we only accepted 99% confidence. Maybe this part we focused on 95% confidence, and using that as an opportunity to make decisions sooner. I have a good friend who is an aide de camp to the vice chief of space operations, and he was like, the biggest frustration that, at least for this my friend's perspective, for that level, was the inability for the engineering community to come back with an 80% solution. Our senior leaders love 80% solutions today instead of getting wrapped around the 100% solution 6 months from now. Because as they're trying to make decisions, 80% confidence is good enough. It doesn't mean you don't go off and do that 100%, but like at least coming back and being like, here's where we feel like it's going is critical, that we need to be willing to put ourselves on that risk pedestal of, hey, I have only 80% confidence. There's a 20% probability that this is wrong, but my bounds are such that like the likelihood that it's going to be a completely 180 answer is so low that it's unlikely. That is useful for our top level decision makers, and that's what I think they're looking for.
An organization that I worked for talked a lot about one-way and two-way doors, right? So the two-way door is we walk through and walk back if we need to, no problem. That one-way door is the one reserved for the higher leadership, because we can't take that one back. So knowing when and where we can go and fail fast is important, and I don't necessarily think that that's something that's well known, especially among the more junior levels within government. So it's great to hear that's trying at least to be pushed down to the person closest to the problem. So kind of along those lines, Mr. Hafey, where do the services work well together in your view, and where do you think we could improve?
So more wordplay. I think the services are working well when they're working together. We saw some great examples of that yesterday with the joint standardization boards, where there's a common need, common interests, and the services get together, share their different experiences, practices. Then we can accelerate innovation by sharing, learning from others, getting new ideas, and maybe we reapply their ideas in a different way. But it's when we're working together, we can accelerate that and kind of spin of the fail fast, right? If we can disagree fast, then we can reach consensus. So while I completely wholeheartedly agree with the reason or that we shouldn't always, we should never do something because that's the way we've always done it. And I hear you on the large committees can slow things down. Large committees with all stakeholders at present are part of the strength of our standard system, and really recognizing best practices, getting those into standards that can then be shared and reused. But while we're in those bodies developing standards, we should work to. We shouldn't expect everyone to just agree. Right? Disagreement is good. I think it was a past deputy director of DSPO that quipped that in standards, if everyone walks away equally dissatisfied, then we did a good job. So.
Well, the DSPO is my favorite office in OSD. I mean, by far. I've been a standards guy for a long, long time, and this move to digital, whatever you want to call it, model-based everything, to me, demands more and more standards. Because if you've been doing this for 35 years, if you are in a paper mode of doing business, and this again, from a government perspective out to the contractors, then your need for standards is way down. When we go to a model-based everything, the need for standards goes way high. And so happy to talk to you offline about that. But no doubt that as we get down this road further, and we're obviously already working, with you guys in this, we're going to see more and more standards that are needed, and we're going to accomplish them. And then that is going to make us go faster.
I would also add that when we want to use a lot of the same kinds of tools, and when we use the same tools, we need better licensing. So we need to get them cheaper because everybody uses Microsoft. Nobody uses WordPerfect anymore. We all use Word for if you have to write a document. But we need to be able to enter into the digital world more cheaply or cost effectively, I guess I should say. But so that's the biggest thing. I think we share information a lot. When we have tools that we say, hey, you can have this tool, there's not yet the reciprocity and the trust between services and missile defense agencies in the fourth estate. But the authorizing official says, well, you have to go through this long process to prove that it's okay to put on our networks. It's okay for the Air Force, but let's look at ours.
So when I think about where we work together, and so part of my job at the OSD level is to kind of be a little bit of a liaison for you guys back to the congressional layers, back to the other federal agencies, and back to our international partners. So I'll talk a little bit about first the congressional layer. So where we work together, you can go look at the latest NDAA budget authorization act. The programs that got plussed up were all joint programs. The programs that got cut were all more very service specific programs. So the classic, the golden rule, the person with the gold wins. Congress is telling us that they like DoD enterprise joint programs, and that the way we're going to achieve that is through strong application of standards. Taking that now to my kind of peers of the federal agency, when we look out across the industrial base, we recognize that our commercial partners are the same across NASA, Homeland Security, the Department of Energy to some extent. And we're finding that our big primes are bidding the same basic things at different rates because we do things slightly different at DoD versus NASA versus Homeland Security. And there's an opportunity for the standards community to continue to develop, to go, man, we can start saving and then kind of building some more resiliency in our industrial base by kind of focusing on joint standards across the federal government. And so that's part of that vision that we have, where we're working through that to invest in the standards and think about how do we go address the gaps. That's partnerships I have with NASA and Homeland Security of how do we kind of divide some of that up so we can best be stewards of the government's dollar. And then at the international level, collaboration with some of my the Five Eyes about how we want to think about standards for the defense perspective. And we're looking at this opportunity to go, how do we better describe the kind of complex nature of the standard space? So I'm sure everyone in this room has seen the XKCD comic that says there's 15 standards, that we need one standard to rule them all. Now there's 16 standards. And so that's maybe a little too chaotic for us in the defense side. But we also recognize that there's no real solution for any given functional area to have a single standard. We need some sort of resiliency in our industrial base. And so how do we start taking those 16 standards and down selecting them to the right set of less than 5? And so that's an opportunity that we're looking at with our international partners in collaboration with my federal agencies of how do we better focus so that way we're not throwing standards out to the program office to be like, you must comply with these millions of standards. How do we better go, these are the 5 we actually care about for this functional area. And when a new one does come up, how do we better then assess and go, what's the opportunity for us to maybe sunset one, bring that one in? Or is this one where we need to go change an existing standard to roll some of that functionality in? So those are all some of the like long-term visions that we're working on to pull in standards to kind of demonstrate how we can work together to actually achieve that kind of mission of delivering capability back to the warfighter.
I kind of see that there's policy up top, there's specifications at the bottom, and then there's this whole gradient of standards. And so what a standard is some person can be different from the next person, and trying to make those work when one person's closer to the policy and one person's closer to the spec, like that's so difficult. That's where I hope to see improvement. And so when I hear you say that we need more standards, part of me wants to say, no, we need less standards. I need to understand what the intent is from the top. And then I would naturally, being, hopefully myself being a logical person, would work through the problem, and it adheres to at least most of the standard versus less of the standard, right? Am I out of line?
Yeah, I mean, we already went through that, right? 92, we got rid of a slew of standards. How's that working for you? Not very good.
Well, okay.
Yeah. Anyway, you didn't live through that, you said.
I was in second grade.
Okay. Well, for those of us who've been around the block 100 times, do take violent resistance to what you just said. And for us to ever have the efficiency of this wonderful idea of going fast, and we don't have the charts that I typically show on very specific things, example that our leadership goes to the Hill, and you can read about this almost every day, and talks about China and how China is going fast. Well, when you're in that kind of environment, right, you end up having de facto standards because of the way they do business. It's not capitalistic. So you and I can take this offline, but it's impossible for us to get to the state of speed that we want without standards. And we absolutely do not have enough standards. And the work that I've been doing for 10 years now is creating more standards in the Air Force. And we're seeing those now after 10 years take off. and allow us to get to the speeds that we've been dreaming about. So I'm happy to answer questions or clarify that, because this does require a long conversation because it gets very specific. But the fact that we need less standards, I violently resist that, and would love certainly have a discussion on why we need more standards and what exactly that means. Because when we say the word standard, that covers just a world of different things. And so maybe you and I possibly are talking past each other. But in my mind, when we move to this new, we call it digital model-based way of doing business, we're actually going to have more standards, if that makes sense. We're going to have more standards because we're going to set up the architectures of our weapon systems, the way our data is structured. And I'm doing that right now. I mean, we're doing multiple efforts in Material Command to get at more standards. And so.
And it's really the data that we're talking about. So the data needs to be able to port, yeah, and the models, yes. And because you want them to be able to talk to each other, even if they're not, or at least share data from one to the next, even if one's Cameo, one's Rhapsody, or other models or frameworks that we have for simulation. We want to be able to share that information, share the data, and not have to translate it 20 times.
Right. And I just recalled I'm going out to be a keynote speaker in next month at GPDIS, Global Power Data Interoperability Summit, I believe, GPDIS, if you've ever been there. I was there 2 years ago. And what I saw 2 years ago in the presentation is actually industries is coming up with more standards in that forum, which I think is the foremost forum of interoperability in the US in regards to DoD. It's mostly a DIB kind of forum. I think I was the only government guy there 2 years ago. Has anybody ever been to GPDIS? All right. Are you a government guy? All right. When did you go? Really? Yeah, well, I was there in 22, and I think they told me I was the only government guy. So I thought, so you must have been there maybe in 21. That's incredible. So you were there, the one government guy. I mean, so that's just wrong. I mean, that GPDIS, one of the foremost interoperability summits in the United States for DIB, the Defense Industrial Base. We had one government person in 21 and one government person in 22. That just shows you, when you go back to that statement of how well we're doing, a D-. So anyway.
And so on the question about, or the topic of less standards, I think where that's coming from is a desire to not have, avoid divergent or duplicative standards. And so we need to constantly be thinking about it. When we develop a standard, we invest in a new technology and we start writing the specifications. When is it appropriate to raise that, to bring that to a standards body, whether it's within a service, within its consortium, or all the way to raising it to an ISO or an IEC. That's how we're going to eliminate that duplication or get in front of it, or the divergence in standards over time. Doesn't mean that we need to reduce the total amount. Yeah, actually, the S-Series was a great example of what happens when we cancel a standard. Now we have many more.
Actually, yeah, that really gets at the heart of kind of what I was dancing around. So especially in comparison to China, where their intent flows down very quickly from top to bottom, versus our strength is our many pipelines there, diversity. So how do we kind of get on rowing in the same direction? So standards, yeah, there you go. Good night, everybody. So perfect. I think maybe I'd like to ask you this, Chris, if you don't mind.
Well, I think that's a perfect segue, and we just
Yeah.
continue to do that, is that we're going to have more standards, and the Air Force is absolutely headed down a path. And I've already mentioned kind of the vision, right? Where we're going to put out a model. That's your RFP. All the contracting is going to be done in a model, whether it's a SysML model or another model, combined with maybe UAF. But we're going to get that back, and we're going to run that through the calculator. and we're going to readily know who the winner is going to be. So what I see us doing is moving more and more toward model-based acquisition. Already, we got approval from my three-star General Morris 2 years ago, November 22. So we've joined forces with Laura Hart and the OMG MBAC, model-based acquisition. We did that 2 years ago in July of 22, briefed him in November 22. He said, full on, let's do it. We've briefed General Richardson, my four-star. I briefed him about a mini brief, a month ago. So we're full on to do model-based everything in the Air Force. We have the POM that's going with that. Phil can talk to you all day about the stuff that she's doing supporting the Air Force. There's no doubt that in my mind that we are headed down that kind of path. We're doing the training. We are working on the infrastructure. It's all going to come together. And I do think 5 years, I don't think we're going to see the, earth-shattering things in 5 years. I think we're still got a long way to go with all the items I just mentioned to you, with reference architectures, with our integrated digital environments, with the infrastructure, with the ATOs that you're mentioning. We have problems everywhere. That's why I gave us a D-. So in 10 years, I think that you're going to see that happening. I think in 10 years, you're going to start seeing your RFPs become models. And I absolutely believe that will be the norm in 10 years and not the other way around.
So I know this is your panel, but I got a question. So as we're looking forward, we as a government have to have the ability to receive that digital data. And when I look at our legacy data systems, even though we might want it badly, we can't receive it right now. We're pitching a ball. We're asking for them to pitch us a ball that we can't catch.
Yeah, for sure. Well, so the Air Force has, just like the Navy, we talked to them too. I haven't talked to Army about this, but we have a log IT, right? A whole radical. We're investing. I don't know. I'm not in that circle, but many, many millions to radically transform our whole logistical operation. And that goes out right now. The schedule is to 2032. And in my 35 years, 2035, that's me, right? So anyway, it still closes in 2032. And so if it's harder, everything we do is harder, but that's 2035. So when you look at just that piece of it, besides all the other, which is a long conversation, happy to have that with you. Yeah, we're making all those changes. Now, how does that get a part of what DLA needs to do? I don't know, but DLA, that comes up frequently, like DLA needs to change their operation also. But I'm telling you, the Air Force is changing. And so if DLA, which I got to believe, that's hope's not a method, but they have to change, because I know the Navy's going to drive them to change too. So internally, Air Force, we're absolutely changing to do what you said. So, 2035, I got pretty high confidence.
Okay.
I'm going to show you the program if you don't believe it.
So has the Air Force applied lessons learned from ESS?
Yeah, ECSS, Expeditionary, absolutely.
So, that was
Absolutely, we have. Into the 100th degree, we've applied those lessons learned.
Okay.
Great. Everything we're doing is in log IT. If you're not
Right.
Are you familiar with log IT and what's going on?
No, I haven't seen it recently. I'll
Yeah.
have to.
We've applied all those lessons learned.
Okay.
Yes.
Good.
Are we applying them perfectly? I don't know, but we have dug through that with fingernails to apply the lessons learned from ECSS to make sure that all the log IT stuff we're doing does not have that, and it won't.
Okay.
It absolutely won't. I'll guarantee you my paycheck, it won't. Is it going to finish in 2032? I already told you, everything we do is monstrously hard, but we absolutely applied the lessons of ECSS.
Yes.
I'm glad they're not in this room, because they would be attacking you right now.
I'm glad you mentioned the logistics part, but it's also the training. So we need to make sure that warfighters are trained on their systems as well.
So is that a technological lift or a person lift? Because when I hear that question, it's like we could do the manual work up front to get everything, in the same format and et cetera. Or do you use AI and ML to kind of do the brute force work for people instead? Or is it like a mix?
Well, no, I think it's both. I don't, and trying to do a sensitivity analysis to figure out amongst the 20 other things that we've talked about, I think is impossible. And we're going to have to iterate on this, right? And that's what they're doing. This is an iterate, another big lesson learned from UCI. Right? So they're MVPing, you iterate, and AI is definitely going to help this tremendously. I don't know how we talk about percentages and all that, but there's no doubt that training is huge. We've already talked about that in this panel, that we have a massive training bow way ahead of us, right, to get our people well adjusted to this new business processes that we're going to do, and we're doing that. We've started that. It's just going to take a while.
One other, this is good, and we've talked a lot about the processes, but we need to make sure that the infrastructure is going to support that. Because if you don't have the models available, you can't get connected. You know, it takes you 40 minutes to get on your computer. You know, that's a big deterrent. And if you can't do a job, if you're not connected at all, then that's also a big deterrent, and people are not going to, they'll either just go home or they'll just start writing documents again.
Yeah. So when I think about that kind of the 5-year, to me, it's continuing to invest in our standards. Using just System LV2 as the example, even though that standard isn't even out of the object management group, it's probably expected in December. I get anywhere from 2 to about 4 small companies, VC backed out of California, coming to me going with, here's this new demo that we can do where we're using, some of them go AI powered, all like innovative approaches just by the application of a new standard. And I go, man, if I can replicate that across the entire engineering ecosystem, if I can think about how do I better kind of connect down to the integration of my CAD modeling and what does that really mean back up to requirements and down through the testing, and I can continue to demonstrate the application of strong standards from these standards bodies, that's going to be super powerful. Then we're going to get more innovation coming in that continues to be a flywheel effect of that acceleration. And that's really where I'm trying to push as we deploy on standards, and thinking all the way down to when we talk about like IEEE standards. Like, just there was had a conversation with someone where they came to a testing event and they were like, okay, we're going to use this IEEE standard. Very clear. Someone showed up with like Ethernet, like copper wire. Somebody showed up with fiber. Both like valid in the specification, but you can't like, and so that was part of the, like, that's an opportunity for us to invest more in the standards to add that specificity. And then how do we actually think about trying to connect them such that when we're doing those engineering, rather than, hey, we always know this wire has to be blue, how do we automate that faster in the tools and have that commonality driven by the tools through the application of those standards? So that's always where I'm trying to push it, by pulling standards out of industry and getting them to be more involved with the standards bodies.
So my question actually has been kind of sitting with me since yesterday, but I think this is an appropriate time to ask. There's been a lot of conversation about getting more government involvement in standards bodies. There's also been a lot of discussion around the fact that standards are often commercially driven. I don't think this is all encompassing, so I think there's pockets where there's probably, push and pull on both of those. But given the fact that a lot of them are commercially driven and some of the technologies that we deal with are very economically, motivated, your cell phone updates, right? All these things go. How do we as the government actually influence that then, if our purchasing power is such a small part of these markets?
So I think there's 2 aspects there. The purchasing power is one thing, being at the table and expressing our needs when a standard's being developed is another. And it's where my focus is. There was a past defense standardization executive. It's now, I think, 3 years ago now, sent a memo that's stated we need to be more involved. We're still talking about it. I know that's easier said than done, right? We need the managers, those that that control the purse strings, to recognize the value of standards, and the long-term investment that it takes. Make sure that we're there when the decision that's going to impact us years down the road is being made.
Yeah, and I'll echo that in the sense that the National Defense Science and Technology Strategy from Ms. Shu says we need to be re-engaging with standards body and being at the table earlier. We may not be able to solve the purchase power of the fact that the federal government doesn't buy nearly as many iPhones as probably the state of California probably buys more iPhones than the federal government. But how do we maybe then change our behavior of, do we need to be more involved in how we work with these RF standards and actually can be concerned about the national security priorities and things like that? There's a lot of trade space there. How we do it is, to me, step one is we have to show up. If we're not even showing up at these standards conversations as the federal government, then we can't even make the right recommendations back to our senior leaders of how to be involved. So I really do think it's critical that all of us continue to take this and we go back to these standards bodies and go, well, rather than us creating a new mill standard, never mind the fact that there's a White House executive directorate that says we should be doing more with standards, we need to be involved and feeding that back to our executives going, if we don't change this now, we're going to screw ourselves up in 10 years. It's always that's a tough trade-off of the cost today versus the cost tomorrow, but at least go in to give our senior leaders that kind of information of what a real technical understanding is and being involved with the standards.
I mean, that's what we're doing, right, with OMG MBAC, the model-based acquisition, right? We're with that. I was there yesterday, right? So we're following that one just for but I definitely agree with them that you got to be at the table.
I think part of it also is being clear on what our needs are, and not just a hypothetical, we need to be able to go fast. No, we need like a tangible target, and then industry can go and make it happen.
Oh, that's right. And if you ever been to those standards bodies, right? If you don't have your stuff together and you come in there, they'll railroad you, right? I mean, because these are brilliant people, right, that come to these meetings, and so you can't talk vague generalities with them.
If I could ask Linda, where do you see injecting standards in the process to encourage our capabilities, and maybe where should we avoid standardization?
Well, I would start the data and being able to share that. And so, and anywhere you have some kind of, whenever you have an interface between two different systems or two different groups that have different tools and things, you need to be able to share information. And if you can't have the same tool, you need to be able to, you don't want to translate it from one tool to another and then back to, because there are things that can get lost in that translation. So, and I'll go ahead and get onto the other one. Where do you want to avoid it? I mean, everybody, shouldn't say everybody, vendors have their secret sauce. You shouldn't try to standardize what they're doing there. And intellectual property, you have to be able to respect that. But anytime you bring two things together, you have to have some kind of standardization.
Yeah, I mean, so specifically what I've been doing the last 12 or so years, which is just continue to grow in the Air Force, is that we are focused on injecting standards which the commercial world doesn't care about, right? And nor have they even tried to care about it over the last 70 years. For example, with avionics systems in our military planes, Air Force, right? They haven't gotten into any kind of open standards that allow avionics boxes to talk to each other. And if you go back 10 years ago and you start talking to people about avionics standards and somebody says, oh, 1553, and you go, what are you talking about? I go, yes, I mean, it's a slot profile, but it's like, has nothing to do with an open standard. Yeah, you can use it, but it doesn't make your avionics interoperable at all. And so for the Air Force, that's OMS UCI, right? That's our interoperability standard to move bus message traffic back and forth between avionics. EW is big iron. PNT, position navigation timing, is resilient EGI, embedded GPS, INS. So I could go down a big list and tell you for radar, we're struggling a little bit there, but we're for weapons open systems architecture down in Eglin. So we're targeting those areas that the commercial sector cares nothing about. And frankly, when we move to a model-based way of doing everything, trying to get the right standardization from our bombers and our fighters and our ISR and our heavy military and our special ops aircraft, there's a fundamental aspect of that when you architect it, like in SysML, that is exactly the same. All of them have hydraulics. All of them have PVI. I mean, I go down the list, right? They all have all these functions. So when you do a functional decomposition or you look at how you're going to architect that, I could show you something and you would never know if it's a C-17 or if it's an F-22. I mean, obviously, when I get down to more specificity, you finally go, oh, it's an F-22. But you wouldn't know that at a certain level 3. You have no idea. And so we're coming up with reference architectures. I'm working that in my office where we're describing air vehicles at a certain level. We're still iterating on that. We've gone through and we've worked a little bit with Mike Heffy and the group here on converting 36 standards, JSSGs 2009 in one case, as well as a bunch of other standards. And those are all available to the community now. We've converted them. We're still adjudicating them, right? But that's how we want to do business in the future. When you get the model, in the RFP as the model, it's going to come, right, with all of the other models that you're going to need, including standards, right, to do your design or your modernization. So we're targeting back to this, we're targeting those areas that the commercial world cares nothing about. And we've needed for so long. And this digital move to model-based everything really is accelerating that.
One of the few things I remember from grad school, one of my professors, he was a Stevens professor, he emphasized that the hardest part in engineering is at the interfaces. And we have a slew of new interfaces and new tools, and that seems like a perfect place to have new standards.
Yes, and the other thing that we've figured out as we've gone through this over the couple of decades now is looking at where you have the most change. So where the Air Force is getting crushed is particularly avionics. We're just getting crushed with obsolescence and DMS and people wanting to change the software, and then we're just dead. And so as we've looked over our systems, particularly the past 12 years that I've been involved, we've looked at, and then you hit it right on the head, right? I mean, where are the places in your architectural structure that are changing all the time and you're just eating your lunch? And those are the places that we standardize. Like, oh, we're going to standardize right there. So.
Okay, coming down to the wire here. Dan, how does the academic system need to change to produce effective engineers?
So how does it need to change? So I think there's actually great examples where the academic institutions have already started to change. And for me, I'm a big fan of Dr. Soldado at the University of Arizona. He leads, so he has some scope at the College of Engineering perspective. So he leads the like engineering 101 class or something like that. And he literally has his students sign an NDA. And so I'm not going to like spoil what he does because he walked me through what he does. He runs it like a real program where he is changing requirements on the students like at the last minute without them even knowing. And they sign an NDA so that way they don't go tell the next class of students of what his changes are going to be and stuff like that. So they're already thinking about how they build in this kind of cross functionality in, and they've established a joint ecosystem at the college level where professors are all coordinating together. And rather than students doing their work, creating a PDF, emailing the PDF to the professor. It is all done inside the ecosystem where the professors are grading the content. They're actively involved. They're using branching and merging and all those kind of things. And they're acting in a cross-functional team from the mechanical, electrical, civil, and systems engineering perspective, all working together. So we're seeing cases where the academic system is already growing. When we, at the kind of university space, when we take that and apply that to some of our DAU, and I'm not going to like talk for DAU, really, that's a great question for my DAU compadre over here. But they're rethinking the kind of back to basics approach for the acquisition workforce. So how do we provide the right amount of training? How do we shift from that kind of old classroom style where everyone loved 40 hours of acquisition to 100 or whatever it was? It was 40 hours sitting in a classroom. That was the greatest thing at Fort Belvoir. Absolutely love that one. And so they're trying to change that. So that's really an opportunity for us to continue to invest and tell the story of how standards and good digital engineering practices are going to enable acceleration through in that academic approach. So at a high level, we're already seeing changes happening. I mean, it's just going to take time as the colleges of engineering start acting like a college instead of individual departments as they break down their own silos. So we're seeing cases where that goes. But I know DAU is doing a lot of great stuff. And we, within my office, set the credentials that then DAU executes on. So we have credentials around digital engineering for what we're expecting that then DAU builds coursework on.
That's really refreshing because I remember, being out of college and coming to the workforce, and people can't wait to tell you how you don't know anything about anything. And like, okay, I understand, but like, how am I supposed to know? You're the experienced person with the contacts. I came from a school, where was the disconnect? So it sounds like that gap's kind of closing.
So let me just talk to that a little bit. So I'm rewriting one of my classes. It's the most technical class that I have in my portfolio. It's called supportability analysis, and we're doing a reverse classroom. And whereas the typical stage on the stage professor stands up there and drones on about all the technical information, that's all going to be done virtually. You're going to have asynchronous learning. You'll be able to read it and review it and review it. It's all mostly videos and little short 7-minute video, 5 to 7 minute clips. You'll be able to review each one of those an infinite amount of times. And then after that, we have a synchronous piece where the students come together and we have discussion. We talk about lab learning. We talk about, what did you learn? What didn't you understand? And it all becomes purely discussional at that time. It's kind of like, a reverse classroom. I saw this done at Georgia Tech, and it was very effective in the engineering department. And so we're cutting the quote in classroom time down from a 40-hour class down to probably maybe 3 hours of asynchronous learning and 3 hours of synchronous learning for each day. So and the synchronous part is going to be all discussion. So yeah, and the credentials, 99% of them are all 100% online. You don't even ever have to walk into a classroom. You do them at your pace, and it's fully automated. So yeah, I believe that the educational system, both in the mainstream academia and for the acquisition workforce, we're trying to adapt and change as fast as we could. When the pandemic hit us, we didn't shut down. We just moved right into Teams and started teaching those classes over Teams. It was tough at the beginning, but all our courses have adjusted and to be more remote virtual delivery. And so absolutely, I think academically we've reacted to try and adjust to the way the new learning model is for the adult learner.
Yeah, that's perfect, because part of the genesis of this question was I remember being in class and my professor would spend the whole period deriving an equation that's already in the book and then testing us on how to answer questions. It's like, well, could you have taught us how to answer the questions during the class time? So hearing that, the reverse approach sounds really amazing to me.
And it is always that trade-off of, I mean, I love my PhDs in the room, and there is that kind of academic cycle, and I don't want universities just to be producing people to go into the workforce. And there is that need for that academic research and continuing to evolve that. But it's always good to see where our students are coming out of the undergraduate levels and the graduate levels, and they are capable beyond belief. I've had the privilege of seeing interns coming out of the Air Force Academy where they would brief senior leaders, SESs, and the SES would turn to the contract, the PM, and be like, why was this guy able to do it in 6 weeks when I've been asking you to do this and this is like 500-person contract. Why have you not been able to do this? And just the blank stare. So our workforce is growing, but they need to continue. We have to continue the charge of pushing against the IT infrastructure. There's a quote from I think an Air Force CIO that said, every time he sits and looks at a spinning like cycle on Windows, he sees an Air Force captain leave. And that's just the reality of just the speed that we have to continue driving and pulling those young engineers in. We have to continue fighting against you want to do real work? Well, here's PowerPoint. We don't actually use those tools. We need to give them the tools, let them do their jobs.
And so the last prepared question. Oh, sorry, go ahead.
Thank you. I just wanted to add to that. I was talking with a professor who teaches at Embry-Riddle a couple months ago, and she took an SAE standard and converted it. It was AIR 6110 and converted it to a model, and she uses that model to teach her students. And the students go in and they learn to perform FMEA analyses and requirements tracking within the model. So I think it's already changing. There's already people bringing in that technology and introducing digital engineering to students and giving them kind of hands-on applications so that they can see what it's going to be like whenever they graduate into the real world.
So that makes me feel old now because I didn't get that in my undergrad. So that's wonderful. So final prepared question, Mr. Havey. How do you think we can improve engagement then with academia, with our sister services, and industry in general?
So we already talked a lot about participating. Specifically, there's a number of organizations that the DoD participates, and we adopt standards from over 100 non-government standards bodies, and there's numerous committees in each of those, and there's sometimes members from different services and agencies and federal agencies in those. ANSI is one forum where you heard from Mary Saunders this morning, where we get to interact with our government counterparts, the government member forum and their national policy and international policy advisory groups. And the collaboratives that Mary mentioned are also excellent areas where we've partnered with other federal agencies. And you mentioned partnering, I think earlier, with NASA. There's through the implementation of the National Standard Strategy for Critical Emerging Technologies, there's been an increased interest in partnering across the federal government, sharing information about where we are engaged in standards and working together to be more proactive, less reactive about addressing standards gaps, particularly when it comes to critical and emerging technologies. But all that comes back to, we need to be at the table. We need to be out seeking those opportunities to engage. And so if y'all take nothing else with you this week, right? If you're just better equipped to talk to your leadership about the importance of standards and helping gain the resources needed to pay for memberships and travel and the time commitment to investing in standards, then I hope that's one thing that you get from this week.
Yeah, you have to be there, right? Well, so that kind of concludes our prepared questions. This word cloud is just a taken.
I'm sorry, I have a question from the online audience. How hard would it be to change the US to metric?
Yeah, that's a culture change question.
You could have them contact DSPO. We have a guidance document on that, and we can take that one offline. It's lunchtime.
Yeah, actually, we are coming up on lunchtime, but I think we have a few minutes for any more questions from the audience. Okay, well, I guess that concludes this production, Jazz Hands. So hopefully you all enjoyed, and I really want to thank the panel for coming here and indulging my questions. So I really appreciate it. Thank you very much.